Hello to all of you. This is Dr. Dhaval Maheta, and today's the discussion topic is confirmatory factor analysis. The basic difference between exploratory factor analysis and confirmatory factor analysis is that in the case of confirmatory factor analysis, we are having some model or some structure, that is a relationship between the indicator variables and constructs are well defined. We are very clear while collecting the data that this statement will be loaded on this construct. You can see here that this is one model where x1, x2, x3 are the statements and they are going to be loaded on visual. x4, x5, x6 are the statements which will be loaded on textual. x7, x8, x9 will be loaded on the construct which is speed. In case of exploratory factor analysis, we don't have such model. We actually in our previous videos we have discussed that we will be creating the structure, right? Now let us understand that to carry out the confirmatory factor analysis, which package is essential in R. So you will have to load the package which is lavaan, developed by Yves Razel. This package is having a capacity. It can fit a variety of latent variable models, including confirmatory factor analysis, structural equation modeling, and latent growth curve models. Moreover, this model is, you can say, it fills a gap between the advanced graphic user interface PLS models which are available. It fills a gap. It's less time consuming. Moreover, apart from this, it is a open source community. The dataset which we'll be using here is Holzinger and Swineford dataset of 1939. Basically, this dataset consists of 9 indicator variables. It consists of the mental ability based test scores of children from 2 different schools. 7th and 8th grade children were considered, and the indicators were x1, x2, x3 are the indicator variables for the visual factor, x4, x5, x6 are the indicator for textual factor, x7, x8 and x9 are the indicators for the construct which is a speed factor. And now we want to carry out the confirmatory factor analysis on this data set, which is a default data set available in the lavaan package. Now there is a syntax which we'll have to understand while carrying out the confirmatory factor analysis in R. So whenever you specify any construct, it is written as latent variable. Construct will be written on left hand side and all the indicator variables will be written on right hand side. Latent variable equal to tilde indicator 1 plus indicator 2 plus indicator 3. Now this you will have to write for all the 3 constructs. You don't have to connect residual variances as we have to do in another software. It will add automatically. All the residual variances will be added automatically. Moreover, all the constructs covariances will also be added automatically. You don't have to do anything. Now let's see how we will do this in R. First of all, you will have to load the package, the lavaan package by the command line install.packages lavaan. Activate the library lavaan. Now, first of all, what you will have to do, you will have to specify the model. I am specifying the model as confirm model. This is a name, you can write down any name, right? It is not necessary that you should follow the same terminology on left hand side. I'm talking about left hand side. But when you are on right hand side, you have to follow the syntax which is there, the default syntax which is there. Right now, how will you assign the indicator variables to the construct? So what you will use, you will write the command single inverted comma construct. First the construct will appear equal to tilde x1 plus x2 plus x3 textual, x4 plus x5 x6 speed equal to tilde x7 plus x8 plus x9, and then you will close with single inverted commas. Make sure single inverted comma, you open the model with single inverted commas and close it with a single inverted comma. When you will load it, when you will run it, the model will be loaded. Now comes creating the model, that is running a confirmatory factor analysis. So for that, what you will use, model is equal to CFA. You'll have to specify the model. That is basically you are specifying the relationship between the indicator variables and the construct. Data is available. That is you can say data is available in this library of lavaan. Run it and you will get the model. Now, how the model is performing, for that purpose, you will have to run the summary. Now, see what it gives you. Summary, it gives you the full report card of your model. It will give you estimator, that is maximum likelihood. It will give you the maximum likelihood. Okay. Then it will give you degree of freedom, p-value, test statistics, its p-value, comparative fit index, CFI, Tucker-Levy index, log likelihood user model, unrestricted model, Akai-K information criterion, Bayesian information criterion, then RMSEA, root mean square approximation error, RMSEA at lower 90%, upper 90%, p-value of RMSEA, standardized root mean square residual, and then you will get the estimates of all of them. Now, one thing which you should observe here is that x1, x4, and x7, its estimates are 1. This we will interpret later on, but why it is appearing 1? Remember, in your model, whatever you specify as the first indicator variable, the software will consider its estimates as 1. Okay, this I will explain later on also. But now let us try to evaluate the performance of the model. So first of all, we will start with CLI and CFI and Tucker-Levy index, CFI and TLI. Let us see what the interpretation turns out to be. Basically, it indicates that a model is fitting the data or not. The threshold limit of all these indexes are 0.9. Nearer to 0.9, it means that the model is fitting to the data appropriately, right? Then we are having some criterions also, like a Akai-K information criterion and Squad's information criterion, Bayesian information criterion. The thing which you should remember in all this criterion is that, say for example, if you are having two models and you are having a Akai-K information criteria of both of them, you will select the model whose AIC is minimum. The bottom line is lower the better. The value of AIC minimum is better, right? Then we will carry out RMSEA. We will get the statistics of RMSEA. Let us see from where I can get Akai-K information criterion. See, here it is. Basically, Akai-K information criterion is, you can say, with reference. If you are having two models and you will compare it. Now let us see RMSEA. Root mean square error approximation. Its value should be nearer to 0.08. Then it is considered to be that the error is less in your model. How we will write the interpretation? Let's see. So root mean square error approximation refers to residuals. It should be as low as possible. The model having lower RMSE is better. If the p-value is greater than the model, then the model has a close fit according to the RMSEA. See, the desirable value in this case, this p-value should be more than 0.05. But here we are getting it less than, it's fine. For analysis, we will proceed further. Here we are getting it less than 0.05. Actually, it should be more than 0.05. Right. Another thing which we have to understand is this value should be nearer to 0.08. Moreover, the 90% confidence interval for the RMSEA is between 0.071 and 0.114. This is also very nearer to 0.08, and therefore we will say that the model is fitting the data appropriately. Then we will carry out the regression weights. It gives me the analysis also gives me the standardized regression weights as well as the unstandardized regression weights. What is a desirable value in this case? The desirable is that the p-value of all this should be less than 0.05. Then only these indicator variables are significantly contributing to the construct. Here we have calculated for x1, x2, x3, and the desirable thing is that its p-value should be less than 0.05. Let's proceed further. We will have to check some other measures also before interpreting the model. So for this, I'll be running the command fit measures model, and I'll get range of statistics. The first thing which you should see here is the chi-square and the degree of freedom. Basically, it is an indicator of the model fit. Normally, we take the ratio of chi-square divided by degree of freedom. It gives me the model fit. Another thing which you should see is all CFI, TLI, NNFI, RFI, NFI, PNFI, IFI, RNI. All these indexes should be nearer to zero point 0.9. If they are nearer to zero point 0.9, then it's considered to be that the model is fitting to the data appropriately, right? Let's see how we will interpret. Remember this value 85.306 and this is 24. Let's go on the PPT again and we'll try to interpret this. The p-value of chi-square is less than 0.05, which means that the null hypothesis is rejected and the relationship exists between these constructs. It's really, we should consider this. See the p-value. Let's go back. This p-value. If it is less than 0.05, we are rejecting the null hypothesis and therefore model exists. We can create the model. Okay, let's come back here. Now, the minimum discrepancy is indicated by chi-square. It is 85.306 and the degree of freedom is indicated by 24. So we will take the ratio of this. The recommended value is less than 5. This means that the model is fitting the data appropriately. Now, the goodness of fit index, I have already displayed you. I have already talked about this, that all these indicators, these indexes should be nearer to 0.9, all this, which shows that model fits the data well. Now, R will generate two indexes. One is a goodness of fit and another is a badness of fit. Goodness of fit we have evaluated. Now let's talk about the badness of fit. In this category, there are two things. One is root mean square residual and another is a RMSEA. The root mean square residual, it should be as low as possible. Here I am getting it 0.082. I'm not talking about RMSEA, I'm talking about root mean square residual. Let us see where this figure is. This figure will be located somewhere here, RMR. Let me try to find out. You can see this value, RMR 0.082. This should be as low as possible. Moreover, RMSEA should also be nearer to 0.08. It means that the model is having 8% error. Okay, let's proceed further. Now we will have to we will have to carry out the parameter estimates, and for this the command line is, again I'll go back in R and I'll run parameter estimates model run, and I'll get the contribution of each indicator variable on its construct. See, LHS construct RHS indicator variable. Got it? The p-value is there. So it will not generate anything related to x1, x4, x7 because we have specified x1, x4 and x7. Basically, it will convert this first indicator weight to 1. This is done to get the degree of freedom. Then only it will be able to estimate, otherwise it is not possible, right? Now, with reference to x1 as 1, we will get all the other values. So I'm getting the estimate of x2, 0.554, and we will have to see the p-value of it. It is less than 0.05. This is really, really good. Now, what will be the interpretation of this? Let's try to understand. The contribution is 0.554, 0.729. Let's try to interpret. Now, x2, it means that for every increase in 1 unit of x2, by 1 unit, x2 is increasing by 1 unit, your latent visual ability will increase by 0.554 units. It is contributing positively. That is our interpretation, right? You can see here, each and every indicator variables are contributing significantly. You will have to interpret this thing till here. I'll highlight this. which means that your confirmatory factor analysis, or rather the model, is fitting the data appropriately. Okay, let's proceed further. Now, in case there may be a possibility that the model does not fit the data properly, or when I take the ratio of these two, it is more than 5, right? It is more than 5. If I take the ratio of chi-square, that is discrepancy to the degree of freedom, the value turns out to be 5. Then what are the remedial measures? What steps can be initiated to improve the model? Now there is a concept of modification indices. First of all, we'll have to run this. What is the command line? Modification indices model sort true. It means that you arrange it in the increasing order, and minimum value should be 20. That is, this index only generate those relationships whose value is more than 20. When I'll run it, I'll get two values. When I connect visual with x9, my modification indices is 36.411. When I connect x7 with x8, my modification index is 34.145. Okay. Now, this relationship, when we carry out, or rather when we connect this relationship, we will be reducing this discrepancy. That is a chi-square, we will be reducing it. But there are some rules which we'll have to follow. See, this is first factor and 3 indicator variables are there. Second factor, 3 indicator variables are there. Now you can connect the errors of the indicator variables within the construct only. It means that, say for example, modification indices is saying, is giving me the output that if you connect E5 with E6, you will be reducing the chi-square, that is a discrepancy, by this much amount. So the permissible connections are, you can connect within the construct only, right? Within the construct, you cannot go beyond this. For example, I cannot connect E2 with E6 because they belong to E2 and E6 are the errors which are from different construct. I cannot do this, unacceptable. Okay, I cannot connect variance 3 with variance 4, that is also not possible, unacceptable. Okay, I cannot connect even with the original construct, that is also not possible. So the only permissible way in which I can improve the model is connecting the errors within the construct itself. Okay, let us again go on the output and try to see. We are having x7 and x8. Just a minute, if I know that will be too much. Yeah, visual with x9. Can I connect it? Let's go in the model itself. Visual with x9. Visual with x9. Can I connect it? Not at all. Okay, you cannot connect it. Okay, let's go back and try to understand. Can I connect x7 and x8? X7 and x8, definitely I can connect it because they are the part of same construct. Okay, let's do this. So now what will happen? Just observe one thing. When I run this analysis, this chi-square will minimize. And as numerator will minimize, what will happen? The ratio will definitely come down, and it may be below 5. But one thing, again, we are already having the ratio less than 5. In such scenario, you don't have to do the modification indices analysis. This is only to be done when your model is not fitting the data appropriately, or your model fit is more than 5. Okay, so what will happen is, let us see the modification indices first. This modification indices, it's giving me the output as, when I connect x7 with x8, 34 units will come down. 34 units will come down. Let's see. This 85, you can write down on one piece of paper, 85 minus 34. Approximately, the value of chi-square will decrease by this much amount. Okay. Now we will have to do some modification on the original model. This thing will remain same. And now I'll say that I'll connect x7 with x8. Run. And then again I will run the model. that is model 1. I'll again run it and I will see the fit measures. Okay, can you see now the chi-square has reduced by this much amount? And now what will be our interpretation? Let's go back on the PPT again. Yeah, this one. So as the p-value of chi-square, it is less than 0.05. But this chi-square, which was 83 somewhere, now it is 53.27. And again, when we will divide by the degree of freedom, that is 23. Now this value has reduced to 2.31. Previously, how much was it? The value was how much? It was 3.55. Now the value has reduced to 2.35. Now we want to compare that which model is the better model, right? And for that we'll be using the library, which is a SAM tool library. Okay, I'll take this down and I'll keep this script here only, right? And then I will activate the library SAM tools. Just a minute. Enter. Delete. Now this library or this package is having the capacity to compare the two models. First of all, let me activate this. What is a command line? Command is summary, compare fit model, the base model. See, this was a base model without the modification, and this is model 1. I'll just enter summary, compare fit model 1, and I'll get the output. Now this output is, you can say, self-explanatory. You are getting range of statistics. The only thing which you have to search is dagger. See this dagger. Can you see this dagger? The software has identified the base model on its own. You can see the dagger is there on the model 1, and therefore this is considered to be the best model. Now if you want to go in detail, it will give you the comparison. See, RMSEA of this model 1 is 0.066 and of the base model is 0.092. CFI, TLI, SRMR, AIC. See, AIC is now lower. Bayesian is also lower, right? And chi-square and DF, that is when we are taking the ratio, this is a lower, and therefore this model is considered to be better model fit, or rather this model is fitting the data more appropriately in comparison to the base model. Okay, let's proceed further. Now I want to represent all these things on some chart or some, you can say, some graphics. And for this you will be installing the package samplot. Once the samplot is installed, activate its library samplot. What you will have to do? Sam paths. See, just write on the model. Layout is tree. What it means that what output you want to represent on the canvas. So I am saying standardized estimates. I want to have it. Rotation 1, color 4. And it will generate the very beautiful graphics. Now the important thing which you should understand in R is that all the softwares which are available in the market, in this case you have to draw this diagram and the analysis will start. In case of R, you are defining the relationship and the diagram is drawn by the R automatically. We have not done anything. Rather, we have just specified the equations. See, the covariances are connected on its own. The errors are also placed on the constructs. See, the errors are also there. Can you see? Now, if I will run model 1, please pay attention here, all of you. When I will run model 1, what I have done is we have connected x7 with x8. Is it so, no? X7 with x8, yeah. When I will run this, you can see some point between, just see, x7 and x8 was connected, and therefore our model was fitting the data more appropriately. This was not there in the base model. Let me run the base model again and you will come to know what the changes have happened. See this. Okay, now how to understand this model? More the dark line, more the influence, or rather more the impact is there. All these models are reflective at present. We are not working on formative skills. These are all reflective models. How to work on how to work on formative models, that videos I'm going to upload, right? Now I can also change the orientation of this. I can choose tree 2, rotation 4, color 2. There are range of things which I can do. Again, I can go for model layout circle. What statistics you want here? Let us try to make some changes on what, and let's see what I'll get. So in what I can specify, I want standardized or estimates. So if I'll write down here as estimates, so it will generate the estimates here, and color is to run, and it will give me the estimates, right? What other type of diagrams I can draw here? Let us go back and let's see styles. The layout is tree, circle. I can also have spring. Let us see what happens if I specify spring. So I can get this type of chart also. If I write down circle 2, right? Is there anything left? Goodness of fit we have discussed, badness of fit we have discussed. Okay, all these codes are available in my book, Data Analysis Using R by Dr. Dhaval Maheta. This book is available on amazon.in as well as amazon.com. For future videos of R and for the videos of data science, machine learning and artificial intelligence, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Thank you to all of you.